answer these IMF questions, I need to start by classifying all of these types of molecules. To do that, I often will look at metal and non-metal, non-metals only, or metals only to first decide, are we dealing with ionic bonds, covalent bonds, or metallic bonds. The exception to that, carbon and SiO2, regardless of the fact that they're non-metals, when it's carbon by itself or SiO2, we know that that is a network covalent molecule. For every, so this is also network covalent. For everything else, I need to first identify ionic bonds, metallic bonds, or covalent bonds. If it's a metal by itself, it will be metallic. A metal with a nonmetal will be ionic. And these last two will be covalent. For the covalents, I need to further break them down into polar or not, because that's going to change our answers to some of these properties. In order to do that, I need to draw their Lewis structures. HF, that's its Lewis structure. While there's no central atom, I see a hydrogen bonded to a fluorine. If hydrogen's bonded to F, O, or N, we know we have our H bonds. So it's a molecular polar molecule with H bonds. NH3, if I draw it, I'm going to go down here. I end up with this as my Lewis structure. Because of the lone pair on the central atom, this is a molecular polar molecule. There are no H bonds because even though there's, there are H bonds because I have a hydrogen connected to nitrogen. So it has to be connected to F, O, or N. So this is another case of a molecular polar with hydrogen bonds. Okay, now that I've classified them all, I can go through and answer these questions. Dipole-dipole forces between molecules. That will exist anytime we have a polar molecule. HF and NH3, they're polar molecules with H bonds. So yes, they have hydrogen bonding, but they're still polar molecules. They still have dipole-dipole forces. So I'm looking for anything polar would be my answer here. HF and NH3. Covalent bonds exist anytime we have only nonmetals. So whether they're polar or polar with hydrogen bonds or nonpolar, that would make them covalent. Additionally, network covalents have covalent in the name. So essentially, covalent bonds, anything that's not ionic, not metallic. We get carbon, we get HF, NH3, SiO2, and that's it. Things that dissolve in water are ionic compounds, molecular polar compounds, and molecular polar compounds with hydrogen bonding. So not covalent, not network covalent, but HF does because it's polar, NaCl does because it's ionic, NH3 does because it's polar, but not the network covalent, not the metallic. Dissolve in benzene are only nonpolar things. I don't have any molecular nonpolars, so my answer here would be no. Things that conduct electricity when they're solid, only metals. Hg is my only metallic compound, so it will conduct as a solid. Now metals will also conduct as a liquid, but in addition to metallic things, ionic compounds, when melted or liquefied, will conduct electricity. That's it.